Hello, everybody. My name is Jeffrey Koss. This is a presentation for a assignment I had in a robotics class over at the University of Advancing Technology. For this assignment, I had to make a motor controller, and this is going to be part of a robot. And let me tell you, it was quite a task at first because I never really worked with H bridges and stuff like that. So it took me a minute to get it, but I got it. So let's dive into code and we'll go from there. So right off the bat, you're going to see something new that I usually don't use, and it's a volatile. Volatile long, and I call it counter equal to 0. And that is because we are using an interrupt. And I'll get back into that in a minute. But for the time being, what you need to know is that I have a device on here that counts. It can count um, revolutions by turning on and off. And I'll show you how that works in a minute. But anyway, these global variables, so the EN, A, and B, those are the enable pins on the H bridge. Then I have left A, encoder right, left B, right A, right B. Oh, hold on one second. I am so sorry about that. So sometimes when I do these videos, I do it right away, right after I get this stuff working. Oh. And this inadvertently got placed in the wrong area. It's supposed to go down here. And the reason why is, yeah. So how did that get there? Sorry, technical difficulty, guys. Give me 1 second. We'll get back into this here. Okay, that looks a lot better. I'm sorry, I'm a little finicky about my code. So okay, the two on the top here is your enable pins. I put them on 5 and 6. Pulse width modulation. Okay, so we can control the speed of that. But I'm going to be honest with you. I tied it right into the 5 volt rail, and as soon as I dropped it, as soon as I dropped the voltage on it, it wasn't working that great. So I just used 255 throughout the thing. Um, these other integers are your controls on the H bridge to make it, do different things: turn left, turn right, go forward, go reverse. This duration is going to be an integer we compare against the counter. Once it reaches that state, it's going to reset itself. Encoder left, encoder right, ENC left, and ENCR. Those are the encoders. I put one on pin 2 and pin 3 because those are the only pins on the Arduino Uno that can read interrupts. And I blew one. I blew the right one. Can you believe that? 5 minutes into the project, it blew up on me. But do you think that's going to stop me? Oh no, we're going to keep going. Anyway, so basically I got it tied into the serial port right now, and these I initiate all of these pins to output. Encoder A and B, I decided to initialize those separately just for something different. And then the encoders, uh, we use an input pull up, and because we want it to be pull up to high. So, like I said, we use an interrupt, and in order to do that, I have to attach it. So I attach the interrupt to digital pin encoder L, which is pin 2. And then I call update encoder, which basically increments counter on the rising, which means that with this encoder, there's a wheel on it, and there are places that are full and places that are not. So the only way I can describe this is, if you're familiar with turbine engines, you know where the stator vane is. So what happens is there's an interrupt, and every time this thing hits a stator vane, it is going to turn off, and then when it doesn't, when it opens back up, it turns back on. So in other words, think of a wheel, okay, with spokes on it. Every time this thing sees a spoke, it closes, and when it gets past that spoke, it opens up. Okay, that's the best way I can describe it to you, and that's how it works. So then in the main loop, we basically just call forward, reverse, turn left, turn right, and stop. These are the 4 functions that I have. And how it works is this. I print to the serial monitor to let you know what's going to happen. So in this one, it's going to go forward. We have a while loop in each one of them. And we say while the counter is less than duration. So basically, this is just my way of being able to control how long this thing's going to go forward for until we shut it off and go to the next function. So the duration is at 500. We set the enable pins to 255, full power. And then these digital writes here, left A, B, A, right A, and right B, we flip these. These go high and low, and determining, depending on what you do with them, it's going to give you a result. This configuration makes you go forward, okay? Then after that is all done, we print out the counter to let you know how, roughly about how many times the revolutions happen. If the counter equals the duration, we set the counter back to 0, and then we move on. So that is the formula for each function, okay, except for the stop function. So here's the thing. So I did an analog rate, and I did drop the voltage a little bit, right around half, and it worked. It worked, but when you put it on the ground, it's not all that great. So if you drop it below this, it just doesn't work right. So honestly, I probably would have used just digital writes for this, turn it on and off, considering that the analog right in this is pretty much useless. But anyway, moving on. So this is going to go backwards. This configuration goes backwards. And it does the same thing. Then we have a left turn, a right turn, and then a stop. And with the stop, I just delay. And then I update the encoder. It works great. It actually does. I'm going to show you how it works. I've got the car kind of wired up haphazardly right now, just so it gets working. And it works. You'll see the wheels spin forward, backwards. They turn in opposite directions. One way for left, turn in opposite directions. The other way for right, and then stop. And you will see my blown encoder. But anyway, with further ado, here you go. I am going to show you a video demonstration now. Thank you. Have a great day. Okay. So you go. It's moving forward in the forward position. Now it's going in reverse. Okay, now it's turning left. You see the tire spinning in opposite directions. Turning right or spinning right, going in opposite directions, and stopping. So here's something that I got to point out to you. One of my encoders is burned out. As you can see, only one light's going on, and that happened in the process of doing this. I actually heard it pop, and it smoked, and it stunk really bad. But I got it working with one right now, so it's all good. So, and this is just the start of it. And it goes in sequence. So there you go. Forward, reverse, left, right, and then stop. And it repeats itself. And that's it so far.